All right, if you would please grab out your dealing with data unit assessment review, and we're going to go through question by question. All right, so number one, the manager of a music store surveyed a random sample of customers who shop at the store about their favorite music type. The table shows the number of customers who selected each type of music. So I've got type of music and then I have number of votes. Based on the information in the table, what inferences about your favorite type of music or about the favorite type of music of all the customers who shop in the music store appear to be valid? Circle all that apply. That usually tells me that there might be more than one answer, but we shall see. Okay, so the number of votes for rock, so let's go ahead and look for rock. The number of votes for rock is 37, is less than the number of votes for pop. All right, well, pop has 35. Okay, well, if I say less than and I think of my alligator is 37, is 37 smaller than 35? Nope, so A is not correct. All right, the number of votes for country, which is 27, is less than the number of votes for jazz or classical. Now, this is jazz and classical together. So jazz is 5 and classical is 9. Well, 9 plus 5 is 14. Well, is 27 less than 14? Nope, so this one is not true. All right, the number of pop, which is 35, is 7 times more than jazz. Well, jazz is 5. This is saying this is 7 times bigger than 5. Well, is 5 times 7 35? And the answer is yes. So C is one of my answer choices. Okay, the number of votes for rap is 12, is more than the number of votes for classical, which is 9. So is 12 more than 9? Yes. The number of votes for rap, which is 12 again, is less than the number of votes for jazz or classical. Well, we already did that up here. Jazz is 5, classical is 9, together is 14. Is 12 less than 14? And the answer is yes. So it looks like C, D, and E are all 3 possible answer choices for us. All right, number 2, a survey was conducted to determine the food choices of the 80 students at a picnic. The type of picnic foods are shown in, that's supposed to say the circle graph. Based on the results, how many more students chose pizza than hamburger? All right, so I'm looking at hamburger at 15 and I'm looking at pizza, which is 30. Okay, you can solve this 2 ways. You can find how many kids are in pizza, how many kids are in hamburger, and subtract. Or we can do the subtraction at the beginning. So if I know that pizza is 30% and hamburger is 15%, well, the percent difference between these two is 15%. So I want to know how many more, which means I want to know my part. So I have my percentage, I have my total, I just need to find part. Now, we can solve this with our proportion, part over whole equals percent over 100. And you could have x over 80 is equal to 15 over 100. Or I personally like to use the equation of part is equal to percent times the whole, where the percentage needs to be written as a decimal. So in 15%, I'm going to move it 2 times to the left to have 0.15 times the total of 80. So 80 times 0.15, 0 and 40, placeholder 0 and 8, 8, 9, 10, 11, 12. I have 2 decimal places to give me 12 more students. To give me 12 more. All right, number 3. All right, so a teacher recorded the typing speeds of her students on Monday and Tuesday. The results are shown in the box plots below. Which statements are best supported by the information in the box plots? Circle all that apply. As I told you before, that could be one answer or that could be multiple answers. All right, so the median typing speed for Monday is less than the median typing speed for Tuesday. All right, when I look at the median is this little line here in the inside of my box. And it is telling me that Monday is less than Tuesday. So that Monday is smaller. Well, is this true? Which one has a higher median? Well, Monday has a bigger median, so A is not true. The third quartile, third quartile, that's this one. So if we want to go ahead and label this, this is Q1, this is Q3. This here is my max. This one is my min. And this one right here is my median. Okay, so Q3 is the line at the very end. So Q3 on Tuesday, which is this one, is less than third quartile, or Q3 on Monday. Well, is this one smaller than this one? Yes. So B is an answer choice. The range for typing speed on Monday was equal to the range for typing speed on Tuesday. Well, the range is from the highest to the lowest. Well, it looks like both Monday and Tuesday both have the same high, but Tuesday's minimum is much lower than Monday. So if I look at range as in the spread of your data, so the spread of my box and whisker on Tuesday is spread out further than my box and whisker on Monday. So Monday's range is smaller than Tuesday's range, which means they are not equal. So C is not true. All right, the interquartile range, which in a box and whisker plot, this is known as your box, of the typing speed on Monday was equal to the interquartile range, or your box, on Tuesday. Okay, so this is kind of letting us know to where if we were to take this box for Monday, so I'm going to go in closer. If I were to take the box for Monday, and if I were to kind of shift it over, and I'm going to use a separate sheet here, okay, and I'm going to kind of bend it. If I were to move that box, and if I were to put it almost directly on top of Tuesday, all right, or you can just kind of see, do your boxes both look the same? Even if I did that or look at the numbers, I can almost guarantee to say that both of my interquartile ranges, both of my boxes are going to be equal for one another. So is my box for Monday equal to my box for Tuesday? Yes. All right, and then the last one, letter E. The maximum typing speed on Monday was greater than the maximum typing speed on Tuesday. All right, so let's look at our max. Well, if I look at Monday and Tuesday, which we already discussed, is Monday going to be greater than Tuesday? And the answer is no, they are equal. So it looks like B and D were my two answer choices. All right, number 4, I've got a graph, and it looks like it's the favorite color of middle school students. And this bar graph is done horizontally. The one thing that we need to double check with our graph is we need to check our scale. So our scale is going up by 1, and our categories are here on the left. All right, use the graph above to answer the following questions below. All right, so how many total students were surveyed in the bar graph? All right, so let's go ahead and figure out. So red has 9. Yellow has 4, orange has 3, blue has 9, green has 7, black has 8, pink has 4, and purple has 6. So I need to add up all of my numbers. 9, 4, 3, 9, 7, 8, 4, and 6. I typically try to add my two numbers up, or add 2 up together as I go up. 12, and this should be 13. So I kind of like start grouping my numbers together and add 2 at a time, which makes it a lot easier. 26, 25, and then I get down to 26 plus 25. 5 and 6 is 11. 2 and 2 is 4, plus 1 more is 5, so it gives me 51. Let me double check my numbers here. 9 plus 4 plus 3 plus 9 plus 7 plus 8 plus 4 plus 6. Should be 50. I added something wrong. What? That was 10. 8 and 7 is 15. 9 plus 3 is 12. 9 plus 4 is 13. Oh, right here. That should have been 25. There we go. And that should have given me 50. There we go. All right, I found it. All right, so how many students were total surveyed in the bar graph, which is 50. Okay, what percentage of students chose orange as their favorite? Well, 50 is my total. I have my part of orange, which is 3. So I'm going to use my part over whole is equal to percent over 100. So I'm going to have 3 over 50 is equal to X over 100. You can solve this by using cross product, or we can easily scale this up. 50 to 100 is times 2. What I do on bottom, I must do on top, and 3 times 2 is 6. So I have 6% of the people chose orange as their favorite color. All right, what percentage of students chose blue as their favorite color? Well, blue has 9 over the total 50 is equal to X over 100. And we already know that 50 to 100 is times 2. And I'm going to do the bottom to the top. 9 times 2 is 18, giving me 18% of students chose blue as their favorite color. All right, number 5, I have a dot plot, shows the miles that Ian skated over the course of several days or over different months. And then I've got July and August. All right, so indicate each statement is true or false based on the data in the dot plot. Select the correct answer in each row. All right, the spread, or as known as range, spread also means range, of July is greater than the spread for August. All right, so August, it looks like I'm going from here to here. Let's see, 10, 11, 12, 13. So that's 13 to 5. Versus July, I'm going from 15 all the way to 2. If I look at, or 1, if I look at my numbers, it looks like July has a larger spread than August. So let's see. The spread for July is greater than the spread for August. This is true. The range for the number of miles in July is 15. All right, so the range is the highest minus the lowest. Well, it's 15 minus 1, which is 14. So is this true? Nope, this is false. The median number for August is 10. All right, so August, finding the median, you mark off a high and a low. So high, low, high, low, high, low, high, low, high, low. I end up with 2 numbers in the middle, which means I would have to take the average of them. But since they are both the same number, my median is going to be 10, which is true. All right, the range for the number of miles in August is less than the range for the numbers of miles in July. All right, so I already know the range for July. I need to find the range for August. Well, it looks like 10, 11, 12, 13, 14. Yep. So 13 minus 5 is going to give me 8. So it's saying my range for August, which is 8, is going to be less than the range for July, which is 14, and that is true. And then the last one, the median number for miles skated in July is 9. So we got to find the median once again. All right, high, low, high, low, high, low, high, low, high, low. And I end up with this number right here. So 5, 6, 7, 8, which the median is not 9, it is 8. So that one is false. All right, number 6, randomly select students from 2 different colleges were surveyed about their preferred studying times. These results of the survey are shown in the bar graph. Okay, so it looks like I have myself a double bar graph here. Where college X is black and college Y is gray. So which statements are supported by the information in the graph? Okay, so the number of morning study time in college X. So morning time for college X is 8, is 2 times bigger than the number of evening study times in college X, which is 4. Yes, okay, college X. Oh, evening, sorry, it's not 4. It is actually, sorry, scratch that, is 2. Because evening is right here. College X is dark. I read that wrong. All right, the number of morning study times in college X is 8. Is 2 times bigger than the evening study time in college X, which is 2. Well, is 8 2 times bigger than 2? So is 2 times 2 8? Nope, that is not true. All right, the total number of study time in the afternoon. So the total study time in the afternoon, well, if this is 3 and this is 7, the total is 10, is 3 times bigger than the total number of study time in the morning. All right, well, morning is 8 and 4. Well, 8 plus 4 is 12. Is 10 3 times bigger than 12? Nope. The total number of study time in the afternoon, well, we just did that. The total study time in the afternoon is equal to the number of morning or evening study time in college X. So morning in college X is 8. Evening in college X is 10. So I've got, where is it? morning or evening together, which is 10. So is the total afternoon equal to the morning or evening of college X? Yes. The total study time in the afternoon, which is 10, is 2 times the amount of the totals of the number of study times for all of college Y. So all of college Y, so I've got to figure out this one now, which is 9. So 9 plus 7 plus 4. Well, 7 and 4 is 11 plus 9 is 20. Now, but here's how you need to read this. I know that 10 times 2 is 20, but when you see it written like this, you have to go backwards. Is 20 times 2 10? The answer is no. And the last one, the study time in the evening is equal to the total study time in the morning. Okay, so it looks like I've got the evening, which is 9 and 2, which is 11, is equal to the total study time in the morning. Well, 8 and 4 is 12. And are they equal? No. So it looks like the only one that is true is the one in the middle. All right, number 7. What can you say about the 2 dot plots? All right, what is the range of the radio listeners? All right, so the highest in the radio is 13.5. The lowest in the radio is 10.5. So I'm going to subtract the 2, 0, 3, and 0. So my range for radio is 3.0. The range for MP3 is 13.5 and 10.5. Well, I just did that. So it looks like my range for listening MP3 is the exact same as for the radio. What is the distribution of music? Okay, so distribution means all right, so you have 3 different types of distribution, and I'm going to show those right here. If all of my dots are right here, and I draw a hill and I have my ball, and my hill is going to the left, this is known as skewed left. If I have all of my dots up here and they're going down this way, and my hill is drawn this way and it's being pulled this way, it is going to be skewed. I can even give you the arrows. Skewed right. And if all of my dots are here in the middle with just a few little on the outside, giving me a perfect, beautiful little hill, this is symmetrical, or approximately symmetrical in that sense. All right, so it's asking, what is the distribution of minutes listened to the radio? So if I were to draw my hill for the radio, it looks like if I were to draw it, my ball is going to be going towards the right, which means it's going to be skewed right. It wants to know the distribution for MP3. Well, let's take a look. If I were to draw a hill for MP3, I kind of get all of my stuff kind of here in the middle, a few on the outside per se. But when I draw the hill, I've got an almost perfect little hill, which means my MP3 is going to be symmetrical. The median for both radio and MP3, remember the median is marking off the high and the low. So let's go ahead and do radio first. All right, high, low, high, low, high, low, high, low, high, low, high, low, high, low. I end up with 11.5 for the median in radio. And then let's find the median for MP3. High, low, high, low, high, low, high, low, high, low, high, low, high, low. And I end up with 12 for the median for MP3. All right, number 8. I have a stacked bar graph that shows the number of students from each grade in the Jefferson Middle School chorus. So if I look at my little key here, it looks like the darkers are the girls and the lighter are the boys. All right, in the chorus, how many 8th grade boys and how many 8th grade girls? All right, so 8th grade girls, it looks like I have 20. 8th grade boys, so if I start here and end here, even though it's up to 40, the boys are just only this little section right here, which is the lighter of the two, which the 8th grade boys is 20. How many total 8th graders are there in the course? Well, all I need to do is add these two up or look at my bar graph to see the top of 8th grade is 40. All right, what is the ratio of eighth grade boys to total eighth graders? Well, I need to find a ratio of boys to total, which is 20 over 40, which this can reduce down to 2 over 4, or it can reduce even further to 1/2. And then the ratio of eighth grade girls to total. So I have girls to total, which again is 20 over 40, which can reduce to 2 over 4 or 1/2. All right, number 9. Miss Watson claims that she always has to wait longer for Miss Bryan to grade test than Miss Smith to grade test. Over the past 9 weeks, Mrs. Watson recorded the minutes it took Mrs. Bryan and Mrs. Smith to grade test. Her data is below. So Miss Bryan's test is here, Miss Smith's test is here. What is a valid conclusion for all the test grades for both Mrs. Bryan and Mrs. Smith based on Mrs. Watson's data collected? All right, the median time is the same for both teachers. All right, so 1, 2, 1, 2, and I get 5 and 6, which means I have to add these two together. Well, 5 plus 6 is going to give me 11, and 11 divided by 2 is 5.5. I need to go here, high, low, high, low. I get 5 and 7. And the number directly in the middle, because that is what you're doing, is giving you 6. 5 plus 7 is 12, and 12 divided by 2 gives you 6. All right, so the median times for the teachers are the same, and the answer is no. Test grading time for Miss Bryan varies more, so my range is higher than Miss Smith. All right, range is the highest minus the lowest. So 9 minus 1, which is 8. 7 minus 3 is, I think that's 4. Double checking. Yep, 7 minus 3, which is 4. So Miss Bryan's range is 8, and it's more than Miss Smith's range, which is 4, and that is true. The mean test grading for Miss Bryan is the same as the mean test grading for Mrs. Smith. All right, so mean also means the word average. And how you find the average is you add all your numbers up together and then you divide by how many that you have. All right, so I've got 1, 3, 5, 6, 8, and 9. Well, 9 and 8 is 17, 6 and 5 is 11, 3 and 1 is 4. So then I have 17, 11, and 4. So what is that? 5, 12, so that's 22. I think 7 plus 4 plus 1. Oh, it's 12, not 22. And then 1 plus 1 plus 1 is 3. So I have a total of 32 divided by 1, 2, 3, 4, 5, 6 divided by 6. All right, so I'm going to go down here to do 6 divided by 32. Well, 6 cannot go into 3, but it can go into 32 5 times. 2, bring down the decimal. 6 can go into 23 times at 18. And I believe this number is going to go on and on and on. Wait, no, not divided by 6. And you're going to end up with that. So Miss Bryan's average is 5.3 repeating. And I want to know, is it going to be the same for Mrs. Smith? All right, so let's do Miss Smith. So 7, 7, 7, 5, 3, 3. 3 and 3 is 6. 7 and 5 is 12. 7 and 7 is 14. 14, 12, and 6. 6 and 4 is 10, plus 2 more is 12. 32. We'll take a look. 1, 2, 3, 4, 5, 6. 32 divided by 6. We just did that, so 5.3 repeating. So Miss Bryan is the same as Miss Smith, which is true. And then the last one, the median testing grade for Miss Bryan is greater than Mrs. Smith. So my median, which is my middle, which is 5.5 for Miss Bryan, is it going to be greater than Miss Smith at 6, which is not true. Miss Smith is greater than Miss Bryan. All right, number 10, I have another dot plot here. The dot plot, or the box plot, sorry, shows the target range heart rates for men 20 to 40 years old and men 50 to 70 years old. Which statements are best supported by the information in the box plot? Circle all that apply, which means it could be one or it could be multiple. We got to check. The range for the men of 20 to 40 is less than the range for the men 50 to 70. All right, so we can kind of see the spread here, and we can kind of gauge or whatever, but we can also use some numbers too. So I've got 90 and 170. So if I take 170, and I'm going to use my handy dandy calculator here, the range for 20 to 40 is 80. And I'm going to do the same thing here, 75 and 145. So 145 minus 75 is 70. Yeah. And that was 170 and 90. Yeah. All right. So 20 to 40 is less than 70, which is not true. The median, which remember the median is the little line in the middle of my box. The median for 20 to 40 is higher than the median for 50 to 70. Well, is this number bigger than this number? Yep. The minimum for 20 to 40, which is this one, is less than the minimum for 50 to 70. Well, which one's smaller, 20 to 40 or 50 to 70? Well, 50 to 70 is much smaller, so that one's not true. The interquartile range, which is known as our box. So we can go ahead and take a look. So the box for 50 to 70 is less than the box for, I was supposed to say 20 to 40. Sorry. 20 to 40. Okay, so we could do math or we can just kind of look. The box here looks a little bit bigger than this box to me. So I would assume that my older box, for the older guys, are going to be smaller than this one. So let's look at this again. The box for 50 to 70 is smaller than the box for 20 to 40. Would we say that's relatively true? I would say that's relatively true. The max heart rate for 50 to 70, so this one, the max heart rate for 50 to 70, is higher than the max heart rate for 20 to 40. Well, is this number bigger than this number? No. So E is wrong. All right, number 11. Miss Bryan asked 20 customers who came through her bookstore how many children books they purchased today. The dot plot represents their answers below. What percent of customers purchased 3 or more children's books today? All right, so I've got to count how many people bought a children's book that is 3 or more. So I see 1, 2, 3, which is all of these. I'm just going to go ahead and circle these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there were 10 3 or more over a total of 20 dot plots, which is X over 100 because I want to figure out the percentage. Well, 20 to 100, we can scale this up by 5. And what I do on the bottom, I must do on the top. Well, 10 times 5 is 50 to give me 50% of the people chose 3 or more children's book today. All right, number 12, a zoo researcher recorded the number of hours that gorillas slept in a night. The dot plot, wow, I really was messing up on my English. The dot plot shows the results. What percentage of gorillas slept 11 or fewer hours in the day? So 11 or fewer in the night. All right, so out of 11 or fewer, I have 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is equal to X over 100. Well, I know that 15 cannot go into 100. I could use cross product, or I see that 3 over 15 can reduce by 3. 3 divided by 3 is 1. I'm going to show you divided by 3. And then 15 divided by 3 is 5. 5 can go into 100 20 times to give me times 20 on top. Well, 1 times 20 is 20%. Number 13, Mrs. Kelso and Mrs. Bonham gave each of their students a small bag of colored tiles. The students each counted the number of purple tiles they received, and the box plot displays the data for both classes. Which statement is best supported by the information in the box plots? All right, the range for Miss Bonham's class is less than the range for Miss Kelso. All right, so remember, range is the highest and the lowest, highest and lowest. So it looks like I kind of got my stuff almost centered. So let's see, is Miss Bonham's range or spread smaller than Miss Kelso's? I would say that's relatively true. The data for Miss Kelso's is more symmetrical than the data for Miss Bonham's. I mean, we can't quite guarantee if it's going to be more symmetrical because when I see this, I think of a dot plot. And I don't have that information, so I can't 100% tell you. All right, the median number for Miss Bonham, which is this one, is less than the median number for Miss Kelso. Well, which one has a smaller median, Bonham or Kelso? Miss Kelso does. So Miss Bonham is less, which is no, Miss Bonham is more. The interquartile range, or also known as your box, for Miss Kelso is greater than the box for Miss Bonham. All right, so is this box bigger than this box? Nope, Miss Kelso's box is smaller. So A is the only one. Even though we found the correct answer on A, double check everything just to make sure that you have the correct answer when you're taking your test or when you're doing anything. All right, and the very last question, number 14. An entertainment company surveyed 360 people to find out their favorite type of movie. The results are shown below. Use the circle graph to answer the following questions. Based on the circle graph, how many people chose comedy as their favorite type? Okay, so I have the total. I have my total, which is 360. And I have the percentages here. All right, I'm going to use the equation part is equal to percent times the whole for each of these if I'm looking for a percent, or if I'm looking for my part. It just makes it a lot easier. All right, so comedy is 35%, which is going to be 0.35 times 360. And I'm going to use the space down here to do my math. So 360 times 0.35, 0, 6 times 5 is 30, 3 times 5 is 15, 16, 17, 18. Placeholder, 3 times 0 is 0, 6 times 3 is 18, 3 times 3 is 9, plus 1 more is 10, 0, 0, 8, and what is that? 6 would be 14. 1 and 1 is 2. Bring down the 1. Add 2 place values, so 1, 2. So there are 124 people that chose comedy. All right, based on the circle graph, how many people chose family as their favorite type? Well, family, I don't know the percentage for family. So I got to figure this out. All right, so I have to add up my percentages, 35, 25, 15, and 5. 5, 10, 15, 20. 3, 4, 5, 6, 7, 8, which is 80, which means family is 20%. So part is equal to 0.2 or 0.20 times 360. So 360 times 0.2, 0, 12, 3 times 2 is 6, plus 1 more is 7. I have one place value here, which is 0.72. Well, not point, sorry, is equal to 72 people. All right, based on the circle graph, how many people chose romance as their favorite? All right, so romance is 5%, so part is equal to. Now, here's the deal with 5%. When you have 5% in any of these percentages here, and I'll show you here, you're always moving your decimal 2 times to the right, which means in 5%, when it goes 2 times to the left, you need to, I hope I said left and not right, you need to move it to the left. And it's always going to have a 0 in front when it's a small decimal less than 10. So 0.05 times 360. All right, 360 times 0.05. 0, 5, and 6 is 30. 5 and 3 is 15, 16, 17, 18. I have 2 place values, which means there are a total of 18 people that chose to watch romance movies. If you guys have any questions, please let us know.